Okay, so in lesson 5.2, we saw how parabolas in the form, or quadratics in the simple form of y equals ax squared, we saw what a did to the graphs, where the curve is either narrow or wide. Then we saw that when we added a k on, as in y equals ax squared plus k, we saw that the parabolas ended up moving from the origin vertically, either up or down, depending on the value of k. And now we're going to look at what happens when our parabolas or our quadratics are in the form of y equals x minus h squared. So now we don't have a k, we just have x minus h squared. And how that compares to our ax squared, we'll be able to see also. So here's a graph of y equals ax squared, and I've already run the values, so we're just going to plot that. When x is -1, y is 1. When x is 0, y is 0. When x is +1, y is 1. When x is 2, y is 4. And when x is -2, y is 4. So we see that this looks very similar to what we have here, but the vertex is definitely at 0, 0. Okay? So when we shift from y equals ax squared to y equals x minus h squared, we end up with just a little bit something happening that moves our parabola horizontally. So I ran the numbers over here, just plugging in various x values, which are x is our independent variable, so we can choose whichever we'd like. I chose -1, 0, 1, 2, 3, and 4. Did the math. Just do a couple of them with you. When we plug in a -1, -1 minus 2 is -3, squared equals 9. 0 minus 2, -2, squared equals 4. 1 minus 2, -1, squared is 1, and so forth. Then we go ahead and plot those points. When x is -1, y is 9. So when x was -1, okay, y was 9. And where did my graph go? Okay, so that's over here. When x is -1, y was 9. When x is 0, okay, y was 4. So here's x is 0, y is 4. When x was +1, y was 1. Okay, then when x was +2, y was 0. That's right here. So we've just graphed those 4 points. When x was 3, y was 1. And when x is 4, y was 4. So when I connect those dots, I get this blue graph here, which moved 2 units over from 0, 0. So it moved 2 units to the right because 2, +2, was our number that was in here. Remember, the form is x minus h. Here's x minus h. H was a +2, so our parabola moved 2 units to the right. So now we see when it's ax squared, it's sitting right here at the origin where the vertex is 0, 0. When it's a times x minus 2 squared, it moved over from the origin. We came 2 units to the right, but it still has that same curve because a is still 1. Our 1 is still sitting in front of there. Okay? So then what happens possibly when our a changes to a -1, as in y equals -x minus 2 squared? Well, based on our lesson 5.1, we should remember that all a does when it becomes negative is tell us that our parabola is going to open downward. So I ran those numbers down here in our t-box, x, and our new parabola minus x minus 2 squared. Ran the numbers, went ahead and graphed those in, and we saw that, again, this mirrors the same curve that we have up here for x minus 2 squared. But now we have negative x minus 2 squared, and we just see that the graph opens downward instead of upward. So basically, it's just showing us that that new form that we have here, y equals x minus h squared, h, the value of h, is translating or moving our parabolas either to the right or to the left. And we're going to see how it moves to the left here. Here we saw it move to the right. We saw that the negative a can make it open downward. And then we're going to see that that graph can actually move also to the left. So by investigating farther, we see that, again, if we have the graph in the form x minus h squared, we have a new one here that they want us to investigate that's y equals x plus 2 squared. All right, so what we're going to see is that that reveals that we have the same curve as x squared, but it's translated to the left 2 units because our h value is actually a negative 2. It's x minus negative 2 squared equals y. Okay, well, x minus a negative 2 is the same as x plus 2. And that's why after we put in our values, we plot our points, we find out that the graph of x plus 2 squared shifted our parabola over to the left 2 units so that our vertex ended up being negative 2, 0. Okay, there's our vertex. Our axis of symmetry then would be x equals negative 2. We have a minimum point. And what else? The vertex, our vertex is negative 2, 0. The only last thing that can happen is if the graph is in the form y equals x minus h squared plus k. When we have both of those things going on at the same time, then the graph is going to shift sideways, either left or right, depending on what h is, but it will also move vertically depending on what k is. And that's what we're going to be looking at next.